Alright, so this video talks about permutations. So this is sort of in the unit with probability, and we've done some pretty basic probabilities of like, well, what's the chance of getting this if I have this? But permutations add a level of complexity to it because if we want the order of which we draw or pick in a certain combination, okay? And permutations often goes hand in hand with combinations. And the one thing you'll hear about permutations is that the order matters. Order matters. Okay? Meaning, the order I draw all of my, or draw something from a deck or pick, it's important that I pick something and then that is it. Typically, with the permutation, I don't replace the object, so with a deck of cards or a lock combination, or with permutations, another great way we think about it is with the order of how we pick particular people in a class election or some type of official election. Another great way we use permutations is like the order of how some athletes finish a running race. Who it's first place, second place, third place, things like that. So, those are all different ways that we use permutations. We'll do another video about combinations a little bit later. But permutations, the big thing is that it's about a particular order. Permutations, particular order. Or as I say, order is very important. So, there's many ways you can look at it. So, numbers 1 through 4 on this worksheet, you simply just plug it in, okay? But if you have a scientific calculator, it makes it real simple. But here's the formula that they're saying. Let's go ahead and write this out. So, NPR... we'll explain what those letters mean. N factorial divided by n minus r factorial. Okay, so just to break down what all these letters mean, okay, the n in front means the number of possible outcomes. Okay, so these are all the things that could happen in this particular event. Okay, so like if I have 52 cards in a playing deck, right? So there's 52 possible things I could draw, okay? And so n would be the total number of possible outcomes, meaning if I'm rolling 2 dice, there are 36 different ways the dice could land. Or if I'm flipping a coin, there's only 2 ways the quarter or the whatever coin it is lands, heads or tails. So n stands for the number of possible outcomes. R refers to the amount I want, okay, or as I like to say, the amount I really want, because there's an R, okay? So that's the amount I really want, meaning of all the outcomes, how many numbers do I want to pick, how many of those options do I actually want in a particular order, so what's the amount I really want, okay? So, I will do number 1, okay, we'll do number 1 together. Actually, let's do number 2 together. It would be a better example. Number 2 together, and I'm going to use both the formula I just wrote up there in red, as well as plug it in on a calculator, okay? And the calculator part's kind of confusing unless I'm there with you. I don't have the guides. My recommendation is just literally go on Google, type in whatever calculator you have, and you can find the, like, so if you type in Casio 780, I'm just making up a calculator number, and type in combinations, permutations. There should be instructions on someone who's gone through that before and how you can solve that. But anyway, we're going to use the formula I wrote in red on top for number 2. Okay? So the P in the middle obviously stands for permutation. Okay? So we're doing number 2. The P in the middle obviously stands for permutation. Okay? Meaning the order is important. So the 6 means that I have 6 possible outcomes, or 6 possible ways I can get that done, and that's n. Okay, and 3 is the number I want, or the amount I really want, and that's r. Okay, so in our formula, if I rewrote it up here, I'll do it back up on top. So NPR equals n exclamation point, which means factorial, n minus r factorial. Okay, and the exclamation point, I hope you guys have seen it before in earlier math classes, but let's say I had something like 3 factorial, okay? So 3 factorial means that I would just, starting at 3, I multiply all the numbers after it. So 3 times 2 times 1. So 3 factorial equals 6. So if I had 7 factorial, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Which that actually comes from the fundamental counting principle, meaning if I have 7 options, and then how many different ways can I select 7 options? So we do with 7 factorial in this case. Okay? So if I were to do 7 factorial, again, I'll do it on 7 times 6 times 5 times 4 times 3 times 2 times 1, I can answer 5,040. Okay? So if I had 7 options and I had to pick a different order for all 7, there's 5,040 ways I can rearrange this particular group. Okay, so that's what a factorial is. So starting at that number, just start multiplying all the way down. Okay, so that's what a factorial is. So for this problem, it says 6 is n. So I'm going to plug in. Okay, I'll do it right next to it here. So 6 factorial over, and then n minus r. So that's 6 minus 3 factorial. Okay? So 6 factorial on top, that doesn't change. But on the bottom, 6 minus 3 is 3. So I have 6 factorial over 3 factorial. Now again, if you had a calculator, you could actually plug that in and get the answer. Okay? But let me show you another way to think about it. Okay? If I had this, like just a standard fraction here, what if I had 4 times 3 on top over 3 on the bottom? So we know 4 times 3 is 12, and 12 divided by 3 is 4. But if I have the same number on top and bottom, or if I can reduce, right, you can always reduce fractions, you can cancel out things that are in common. So again, reducing down to 4, we already got that. But here's what I'm talking about for permutations, or combinations for that matter when we get there. So 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1. And looking at this fraction, I see that there's 3, 2, 1 on top and 3, 2, 1 on the bottom, meaning I can cancel all that out. Meaning I only have to do 6 times 5 times 4. I only have to focus on that part. So 6 times 5 times 4, well, 6 times 5 is 30. 30 times 4 is 120. So the answer to 6 permutation 3 is 120. Okay? So that's the answer to that question. All right? And so for a calculator, you could just simply plug that in, 6 permutation 3. So if I plug it in here on mine, 6 permutation 3, you get 120. So if you have a calculator, technology makes it a lot easier, but if you have the formula, you could do it even if you don't have the technology, especially if you can cancel out unnecessary numbers. And let's think about this for a second. So with permutations, okay, so I had 6 possible choices, right, or outcomes, and I only needed to pick 3. And since the permutation order is important, so if I wanted all 6 options, it would be 6 times 5 times 4 times 3 times 2 times 1. But I only wanted 3 options. So see how I got rid of the unnecessary things at the end? And if I only want 3 of the options, look how many numbers I'm actually multiplying. 6 times 5 times 4. I'm only multiplying 3 numbers. Okay? So that would also work for 15 permutation 4. So instead of doing 15 times 14 times 13 times 12 times 11 times 10, 9, 8, 7, 6, 5, right? It's a long number. You can actually just do 15 times 14 times 13 times 12. Because you only have to pick 4 of those numbers. You only want 4 of those 15. So, anyway, just a way to look at it there. So that's how you do permutations long form. And then if you, again, for recommendation for a calculator, if you need a calculator and you're like, I don't know how to use it, literally look at your calculator, see what kind of brand it is, and type in the model number and type in permutations. And it should show you a menu or a guide of how to get to where you need to be. So this is the longer video explaining permutations. Now I'm going to do a couple more videos, kind of going a little bit quicker through them.